Hello everyone, myself Dr. Tilak Mukherjee. I am here to present my topic on Kerr Nonlinearity on the estimation of the dimensional scalar and vector propagation constants considering a single mode graded index fiber. In the presentation contents of this PPT mainly we will deal with the introduction, what are the existing gaps and the identified gaps, how the Kerr nonlinearity effect affects such a fiber performance. What is our proposed novel method? What are the evaluation guidelines? And finally, we will discuss about the results and discussions. We know that single mode fibers are they are basically free from intermodal dispersion and they transmit only the fundamental mode. For example, we consider a step index fiber or a parabolic index fiber. We have a certain number of range of V values. Now, the knowledge of such dimensional propagation constants are very important to analyze the polarization and birefringence characteristics. Previously, various numerical techniques or approximation methods were used for the linear analysis, and also we also resorted to finite element method also for the non-linear case. But the power series based Chebyshev expansion or the Chebyshev formalism very is with very simplicity and accuracy deals with such calculations, and it is having considerably less computation complexity, and so it justifies its simplicity as well as accuracy, and it can be used for the other types of fibers also, both in the linear as well as non-linear case. Going with the next slide, the existing methods and the identified gaps have been discussed. Mainly the existing methods were like the variational technique or the Gaussian function. Then there was also the finite element method. But all these methods are very much rigorous. They have exhaustive computational complexity. So Chebyshev power series formalism eliminates such complexity without sacrifice on the accuracy parameter also, and it can be used for the fundamental mode also and for the higher order mode fibers also. Now, what exactly is Kerr nonlinearity? It is basically a nonlinearity effect that is because of the dependence of the refractive index that is associated with the electric field, with the intense optical beam that is associated, and when that beam passes through a fiber, then the refractive index undergoes certain modifications. It results in pulse compression. There are also various effects like cell phase modulation, cross phase modulation, then four-way mixing. Okay, now all these methods, then it also helps in the propagation of the optical solitons. The Kerr nonlinearity effect is one important phenomenon observed in the case of optical fiber communication system. Now, in this presentation, we will discuss about what happens when this nonlinearity is absent and what happens when this nonlinearity is present. So we are seeing that the what is the equation for the fundamental scalar modal field and how we define the W, that is the cladding decay parameter, and what is the V? V is the normalized frequency. And what term specify, that is G of R, specifies the basically this specifies the nonlinear term. Now, this proposed the Chebyshev formalism, it is basically a power series expansion. As you can see from the presentation, we are having certain coefficients like A0, A2, A4, A6. We need to evaluate these coefficients, and finally, some Bessel functions are there like K0 of WR or K0 of W. All these points will be evaluated, and based on that, there will be a matrix, and the solution of that matrix, its determinant, and we will find out some solutions for all this. While solving this, we are also using some boundary conditions. What is the suitable range for the alpha values? What is the suitable range for the beta values? And finally, we will arrive at a determinant, and the solution for this determinant, we will search for a non-trivial solution for this 4 cross 4 determinant, and we equate it to 0. If we go for the linear condition fiber, then we will consider G of R equal to 0. And if we go for the non-linear condition, then G of R will be taking a finite value. In this work, we have considered both the positive value also as well as the negative value. So that means there is a consideration for the positive non-linearity as well as there is a consideration for the negative non-linearity also. And accordingly, we will calculate all these things like the cladding decay parameter W, the coefficients A2, A4, A6. And finally, we will calculate the dimensional scalar propagation constant that is U cap and the dimensional vector propagation constant that is U. So these two parameters will be evaluated. So we have considered a parabolic index fiber and the values we have taken are mainly 1.5 and 2.5 the V numbers. And this is the value for the dimensional scalar and vector propagation constant that is the U cap. And this is the value for the same for for considering the positive nonlinearity. So we have actually considered three different cases. One considering the absence of nonlinearity, one considering the positive nonlinearity, and one considering the negative nonlinearity in this slide. So what you see that U cap, that is the scalar propagation constant, that is basically a function of V and W only. But the vector propagation constant, that is V, that also depends on the term delta, that is the relative refractive index difference. And there is a slight, what we see, that as delta increases, U also tends to increase. The propagation constant decrease in case of positive nonlinearity, while it increases for negative nonlinearity. So this is the general trend. So this method is somewhat very much easy and avoids cumbersome calculations. Going by the last slide, what we see that this formalism yields accurate results for the prediction of propagation constants for the V region extending from 1 to 3.5. As we have considered the single mode fiber, so we have considered the region up to 3.5. Beyond 3.5, if we take for the case of a parabolic index fiber, then it is going for the dual mode fiber. That means more than one mode will propagate. Similarly is the case for step index fiber also. Beyond V 2.4 if we take, that is the case of a dual mode fiber. In the second point, we have seen that the Kerr nonlinearity effect, how it affects the fiber performance and its impact is investigated. And what is the method of iteration? That means how these coefficients are used to calculate, like for the values of A2, A4, A6, and subsequently how they will be further used in our calculations. Study of low V region can be helpful for evanescent field coupling and the design of switches and couplers. This evanescent field coupling is a very promising field to design opto electronic devices like switches, couplers, and all these things. So therefore, what we see in a nutshell, that this simplified yet accurate formalism will be extremely beneficial to the system engineers, packers, designers, technologists, who mainly deal with the fiber optic sensors, integrated nonlinear optics, and communication related devices. And this will certainly further pave the way for its future scope in this world of nonlinear optics. Going by this work, we have referred to some important references starting from the year 1974 or 75 to the latest 2022. We have gone through an exhaustive literature survey. What were the existing methods? What were the drawbacks? What prompted us to take this Chebyshev method? And how it mainly deals with the estimation of the fiber parameters in a much simpler way. Thank you. Thanks for all your attention.